Hello everyone, welcome to another video on AWS Lambda and Python full course. So this video is on 10 must-know concept about AWS Lambda. Now that you've already done lots of hands-on on AWS Lambda, this will teach you some of the best practices and key concepts around the Lambda. Okay, the first one is Lambda is a serverless event-driven compute service that lets you run code for any application or backend. So this is what AWS defines as the definition of Lambda function. So before we try to better understand what serverless event-driven compute service means, let's look at some of the offerings from AWS side. So the first one is infrastructure as a service, which means it's more like an unmanaged service. What does that mean? Let's take the case of EC2 instance. EC2 instance, we know it's a virtual server, and OS upgrade the responsibility of the customer. So monitoring, backup, how to set up a backup schedule, failover, all that has to be done by the customer. The other part is on the provisioning. So you will decide based on your requirement what kind of provisioning for the EC2 instance will be done. So whether you want T2, you want M5, you want compute optimize, memory optimize. So depending on the requirement, you will provision and then you will pay based on what you have provisioned. The second class of services, platform as service, which is more like managed service, something like an RDS. So what is an RDS? Basically, you have an EC2 instance. On top of that, you have SQL or any other type of database instance that will be installed. But in this case, any OS upgrades virtual server on which you have installed the SQL instance would be managed by AWS. So monitoring, backup, failover. So you just set up the schedule and then it will take the backup and store it in the AWS backup. So all this is the responsibility of AWS. So what's the responsibility of customer in this case? It is the provisioning. So what kind of instance size you want to provision. So that's your responsibility. Now let's look at a third, what we call as sometimes software service, and in this case, mostly referred to as function as a service, popularly serverless Lambda. So here the OS upgrade, monitoring, backup, failover, provisioning is done by AWS. And the key point here is the provisioning is also done by AWS. Amount of service that you use, you just pay per use. So let's take an example. If in a day your Lambda function is not invoked, then you don't pay anything. If it's invoked 1,000 times, you pay for the number of invocation. Now, one thing to understand here is that Lambda function, you cannot run it by itself. So there has to be an event source, and there are a lot of internal AWS and external services that are going to trigger this Lambda function, and then it does some backend processing, whether it's connecting to RDS or S3 or whatever backend service might be. So what are these event sources? Let's quickly take a look. So I'm here on the Lambda function, and then I will just go to configuration. Then I go to triggers, add a trigger, and you can see all these services can trigger a Lambda function. So it's API gateway, AWS IoT, Kafka, application load balancer, and there are a large number of internal and partner event sources that can trigger the Lambda function. Okay, so that's more on the definition of Lambda. Now the second scenario is, where do you actually use AWS Lambda? Good fit for AWS Lambda. The first one is when the demand is unpredictable. Say you are launching a new application, web application, and you don't know whether there are going to be 5 users or 50,000 users. You don't want to provision for 50,000 users, because if there are not that many users, so you are losing out, you are paying because you have provisioned that capacity. And on the other hand, if you just provision for 5, then if the demand increases 50, so you will have a lot of unsatisfied customers who will not be able to get access to your application. The second one is event driven. When you don't need that service continuously, you only need it when there is an event trigger. So let's take an example. So here is an application. What it does is, you take a photograph, then you upload it on S3. When you upload it on S3, and this is something very similar to what we had done in the earlier lectures. Once you upload this photograph to S3 and S3 event notification triggers the AWS Lambda, this code runs, it resizes the image, and then probably stores it in another S3 bucket with resize photo for web, mobile, and tablet sizes. So here you don't continuously need to run the Lambda. Anytime, only when a new customer or existing customer uploads his photograph, this Lambda function runs and does the transformation. So if there is just one customer that has uploaded the data in a day, it will only run once and you pay only for one time. If it is run 100 times, you pay for 100 times. And we'll get into Lambda pricing subsequent slides. The concept here is when it is event driven and you don't need to run it continuously. So these are the two key use cases for running AWS Lambda. Okay, now the third key concept is AWS Lambda execution or invocation model. So this is an image I got from AWS. So there are three ways in which AWS Lambda can be executed. So the first one is synchronous push. You have the Amazon API gateway here, and the customer has requested to get all the open orders that he has. And once he makes that request, it triggers the Lambda function. Then Lambda function does some backend processing and returns data to the end customer who has invoked the API. Now the key thing to here to understand is that it's a synchronous push. So when he makes a request, he expects a response. So you either give him all the open orders or you let him know that there is an error. So you send him some error message. It will expect a response. So this is common for services like API gateway. Now the second type of invocation is asynchronous. So this is common for services like Amazon SNS, S3. In the earlier examples, we took a look where we uploaded something JSON file on the S3, triggered an Amazon S3 event notification, and AWS Lambda was invoked. But in this case, what happens is that the service that has invoked the Lambda function does not expect any response. So it triggers the Lambda function and then it does backend processing, but it does not immediately expect any response. So that's an asynchronous event. The third type of event is stream or poll based. So what happens in this case? This is very common for Amazon Kinesis. So there will be some data, say log stream data persisted in the say Amazon Kinesis data stream. Then what AWS Lambda does is after certain intervals, it goes and looks for the data in Amazon Kinesis data stream or DynamoDB, and it polls and then pulls all the data that is there within that time frame and then puts it in the AWS Lambda queue, which is then processed by Lambda function. So it's more polling based. So it will, after certain intervals, it will go and fetch the data, most likely in a batch, and then store it in the AWS Lambda. So these are the three ways of invocation of Lambda. Now let's take a look at these three examples. This is from AWS. So in the first one, which is synchronous invocation using API gateway and AWS Lambda. So here you again have the Amazon S3 bucket, which hosts the code for front-end weather app. Now the user clicks on it to get the weather information. This makes a REST API call to the endpoint, which triggers the Lambda function, and then it gets data from the backend and then provides that data to the API gateway, which is then consumed by the user. So this is an example of synchronous invocation. Now let's take the second one, asynchronous invocation. I think we already discussed that in the previous slide. So photograph is taken, it's uploaded in the S3, and event notification triggers the Lambda function. It resizes and then puts it maybe in another bucket from which the user can access this data. But this is not expecting any response like in this case. Then you have the stream based. So here social media data is loaded into Kinesis in the real time. Then Lambda function is triggered. Then Lambda function reads this data in batches and pushes it to Amazon database where it is processed, and then it's available immediately for querying. So this can be of two types. It can either be near real time or it can be real time. So there are some important things that you need to know on AWS Lambda limits and pricing. The first one is that the timeout limit for AWS Lambda is at max 15 minutes. So if your Lambda function does some processing and then makes some database calls, etc., it should not run for more than 15 minutes. If it runs for more than 15 minutes, then it's not a good use case for Lambda. So this is an important thing you need to know when you're designing the architecture and thinking of using AWS Lambda. The second one is memory. So you cannot have more than 10 GB. So earlier it was 3 GB. Now they have increased it to I think 10 GB. So if you need more memory than 10 GB, then it's not a good use case. So what it also means is more memory. So you don't actually define the amount of CPU that you need. You define the memory, and as you increase the memory, you will get increased CPU core. So if the memory is more than 10, it's not a good use. Then the third key thing you need to know is concurrent invocation. So we understand that AWS Lambda is a serverless function. But if you have more than 1000 concurrent invocations, then it might not work. So it varies between 500 to 3000 per region, but for most regions, it's around 1000. So what does this concurrent invocation mean? So let's take an example where there's this first customer and it wants to see the number of open orders. So it uses the API gateway, and then the first time when it requests for open orders, a Lambda function that is configured here is invoked. So say it takes 2 minutes to get that order detail. Now at the this is like the 0th second. Then this at the same time at like 1 second, another customer requests the same data. So this one is still in the process of being invoked, or I mean it's already invoked, but it's running. So now another instance of Lambda function would be invoked, and this will do the processing. So you have already now two concurrent invocations of Lambda. Now at the second line, there is a third one, and this is at 2 seconds, and this one requests the same information. So you have the third Lambda function that has been invoked. So like this, say within either at the 0th second or say within first few seconds, you have 1,000 customers requesting the number of open orders. So you will have a new instance of Lambda function that will keep getting invoked. So that limit is around 1,000. I mean it varies from region to region. Some regions it has 500, so 1,000. So that is something you need to keep in mind. So if you have more than say like 1,000, you have 2,000, 5,000 invocations per second at any point of time, then you need to think whether Lambda function is the right service for you. Then what is the Lambda pricing? So Lambda pricing is based on memory allocated, then amount of memory you allocate between 128 MB to 10 GB, then number of time that function runs, so whether it runs for 1 minute, 2 minutes, 5 minutes, 10 minutes, into number of invocations. So look at it in a little more detail. So here I'm on the Lambda function. So I went to configuration, general configuration. Let me do an edit. So you can see the limits here. The memory limit, set memory between 128 MB to 10 GB. Right, so you can set that's the limit, and then there's also an ephemeral storage limit between 512 MB to 10 GB again. Then you have the timeout limit. So timeout limit, say if I say it's 15 minutes, let me put it 15 minutes 3 seconds. The maximum timeout is 15 minutes, so you cannot have more than now. So those are some of the limits we discussed. Now let's take a look at the pricing sheet just to explain it better. Okay, so we learned that for Lambda pricing, you have the amount of memory that you have allocated, then you have the execution time of the function, and you have the number of invocations. So you need to remember these three things. Let's take an example. Let's look at an example now. Okay, so here is an example. So we have a mobile application backend where the Lambda function that runs for about 120 milliseconds. The memory that you have provisioned is about 1.5 GB, and it is invoked 3 million times in a month. Okay, let's first take a look at how much time in a month it actually ran. So it was invoked 3 million times, and each invocation runs for 120 milliseconds. So you ran it for about 360,000 seconds per month. Okay, now we have got the total time. Now we need to determine what is the memory that's configured and what is the charge for that memory per month. Okay, here is the pricing chart. So for memory and price per 1 millisecond. So if we take a look at this one, about 10 GB, it is 0.000001667 per millisecond. Now we convert, so the memory that we had configured was 1536. So we have 1536 here, and we divide it by the MB 102524 MIB. So we'll get the GB amount, right? That will be about 1.5 or something. And then how much time did it run? 360,000 seconds. So we get the total compute multiplying these two, which will be around 500,000 GB per second. Now there is also a free tier, which is about you can see here 400,000 free tier GB per second, and the total amount that we had got was about 540. So we subtract these two, we get 140,000 GB per second. Now what's the cost? So it is for this one, it's about the 10 GB one, we have about, this is the amount. So you multiply this monthly compute charge with GB per second and into this amount, so you get $2.33. That's how you can compute the Lambda invocation charge for an application before you are deciding whether it's the right function for you or not. I'll provide these two links, and the next we have is AWS concurrency, cold start problem, provisioned concurrency, and reserved concurrency. So I'll discuss this in next lecture, as this is getting very long. Welcome to the second video on AWS Lambda key concept. In this one, we are going to discuss about Lambda concurrency, cold start problem, provisioned concurrency, and reserved concurrency. So earlier, we discussed about AWS Lambda being a serverless solution, but there are some things you need to know while scaling the Lambda function. So before we get into that, let's understand how the Lambda function is invoked and what happens under the hood. So as soon as your Lambda function is invoked, what it does is it downloads your code, then starts a new micro VM. So this is a cold start. So it will take some time to these two activities. Then it will bootstrap the runtime. So it's a partial cold start, and this is based on your optimization. And then finally, it will start to execute the code. So these are the 4 steps it takes before it starts the execution. Now let's look at the second chart. So say you have first request coming in at time 0 seconds. So there's going to be a cold start, these 3 steps that we discussed here. Then the execution happens. Now say after 1 second, and let's say this one runs for about 1 minute. After 1 second, you have another Lambda instance that is invoked. So you have some cold start, and then the execution starts, and it stops after 1 second from the previous. Now at the same time, you have third request, so you have some cold start, and then you have the execution. Now after say 3 seconds, you have another request, so there's a cold start, execution. Similarly for fifth. Now say by this time, after the fifth request has come, when the sixth request comes, the first request has already been completed. So what will happen is that it's going to get executed without any cold start. Now that's because the first one, there was a cold start and it completed execution, but when it runs the second time, there's going to be no cold start. So this is the same case with the request for the previous one that have already executed, and there are some requests in the queue. But what you need to know is, though there is some minor cold start challenge when you are starting the initial few invocations, after a certain point, there is going to be a much longer time that it would take to ramp up without the cold start problem. So after initial few hundred requests, the ramp up rate as per AWS is going to be 500 per minute. So if we are going to invoke, or if you have concurrent requests, say 5,000 concurrent requests per minute, it's going to approximately take you 10 minutes before all those Lambda functions that are invoked will be warm, and then will continue without any cold start. So that is something that you need to take care of and look at if that kind of a ramp up time is okay with you. So AWS gives you a solution to that. What you can do is you can set up some provisioned concurrency. What provisioned concurrency does is configure the provisioned concurrency. So it will keep all those Lambda requests warm, but you'll be charged for it. So earlier we had discussed about AWS Lambda being completely serverless, where you don't need to provision anything. But in this case, if you want fulfillment without the cold start for a large number of concurrent requests, you will need to provision, and you will have to pay for using that provisioned concurrency. Now the second thing is reserved concurrency. So what reserved concurrency means is, say you have application 1, then you have application 2, you have application 3, and now this one is using Lambda, this one is using Lambda function, and this one is using Lambda function, and they're in the same AWS account. Now you know that you have about 1,000 concurrency limit per account, and it will vary a little bit based on the region. Now say this is the first application we are using Lambda in that particular AWS account, and this consumes 800, but this was required to consume 300 each. But if this has consumed 800, then it won't be able to scale up 300. So what you can do is you can use reserved concurrency and say that, okay, this is going to use minimum 300, this is going to use minimum 300, and this is going to use 400. So that will give you 1,000. Now if the invocation for the third one, where the limit is 300, happens at 301, it won't be allowed. So that's how you can divide the concurrency between various Lambda functions in different applications. So there is an interesting example from AWS on how it runs the Lambda function under the hood. So what it says is that it is not possible for them to have a micro VM for each Lambda function that has been configured. So what it does is, say it will have the hardware, which is pretty much the same. Then you have the host OS, and then you have the hypervisor for virtualization. So you have a Linux based physical server with the host OS and the hypervisor for virtualization. Then on top of that, you will get a guest OS. So it's an Amazon Linux based virtual server, very similar to EC2. And then on top of that, you will have a sandbox, which will have the Lambda runtime for that particular function. And then you have your code. So this is shared, this physical machine is shared between many accounts, multiple accounts. Then you have the virtual machine, which is the guest OS, which will be shared within the same account. So you have multiple applications running, then with each one having a Lambda function. So it will be shared between these multiple applications within one account. And then finally, the sandbox, Lambda runtime, and your code would be part of just one application which has the Lambda function. Okay, the sixth one is on the handler function, event, and context. So we already discussed that in a little bit detail in the previous section. But just to recap, so handler function is something that runs your function code based on the events that it gets from the service that has invoked the Lambda function. So here is you have the function here which has two parameters, the event and the context. So let's look at what is an event. So you have the API gateway here where the customer is trying to get data from a particular S3 bucket. So it has JSON file and it has multiple S3 buckets which has different JSON file and different data points. So what the user does is it requests the data from, say, this bucket Walmart and key retail.json. So when this Lambda function is invoked, so what is the event here? The get method, and the parameters are bucket is equal to Walmart and key is equal to retail.json. So these parameters are passed as events to this Lambda function, and then this Lambda function is invoked. So it reads the JSON file in that particular S3 bucket and then gives some response. So what's the context? Context is basically more contextual information around, okay, what was the memory that was provisioned. It gives you some other details more on the metadata side for the Lambda function. Now, one thing we need to know is on AWS VPC, AWS Lambda VPC, is that Lambda service always runs in the Lambda service VPC. It does not run in the customer VPC. It will always run on the Lambda service VPC, which is part of Amazon VPC. Okay, in a way. Now, if this Lambda function, which is running Lambda service VPC, has to connect with any other service, say DynamoDB, Event Bridge, or Amazon Comprehend, it can easily do that over the internet with the public API. So if the DynamoDB or S3 has publicly available APIs, it will connect that and process the events that are required. Now, what if this Lambda function needs to access an RDS database that is within the customer VPC? So in that scenario, what you need to do is, in the private subnet where you have the RDS, you need to create an ENI and then attach security group as appropriate. What Lambda would do is it will be able to connect to this ENI using V2N or VPC NAT. So now if Lambda function it is invoked by some external service, say API gateway, and now it needs to connect to this RDS, what it will do is it will connect to this ENI using the VPC NAT or V2N, and then based on the security group, if it has access, it will get the data and do some downstream processing. Now, the third scenario is this Lambda function needs to connect to, say, S3 here and RDS here, and then it also needs to connect to some service that is out there on the internet. So what it will do is it will connect to this ENI using V2N, then through the VPC endpoints it will connect to S3, and then it will go out using the NAT gateway. So these are three scenarios you need to be aware. And one critical thing you need to remember is that Lambda function does not run in the customer VPC. It runs in its own VPC called as Lambda service VPC. And if it needs to connect to your VPC, customer VPC, then you need to use the V2N. Okay, let's take a quick look. So I'll go to configuration, then just click on this VPC, edit VPC. And then from here, you can select which VPC it needs to access. So that's something on the attaching the VPC to the Lambda function. Now, the eighth thing you need to know on Lambda function is that you can use CloudWatch logs and CloudWatch metrics for monitoring Lambda functions, either for utilization, performance, or error rates. Earlier in some of the other videos, I had shown you on CloudWatch logs that get generated every time the Lambda function is invoked, and Lambda sends the metric data to CloudWatch in a 1 minute interval. So let's take a quick look. So I'm this Lambda function, so I'll just do a test Lambda function, and let me now go to CloudWatch, and I go to monitor, and it's showing some CloudWatch metrics. View logs in CloudWatch. So you can see now some logs have been generated. Let me click on this, and you can see there are a lot of details that it provides. So based on these, you can set some CloudWatch alarms, as I had shown in enterprise use case, based on certain keywords that would send a notification or do some downstream action based on the logs or errors that are generated. Next, we have the environmental variables. So sometimes you don't want to store sensitive information in the code like passwords, access keys. For that, you can use environment variables. There are also, in some cases, you want to store values dynamically. So you want to be able to provide the configuration details, whether it's part of prod, dev, and queue, and you want to change any code. So that you can do through the environment variables. Let me quickly show you. Okay, let me go to the Lambda function. So I go to configuration, then you have environment variables, do a edit, add environment variable. So here you can add environment variables. Okay, environment is equal to prod, dev, etc. So that's how you can use the environment variables. Last but not the least, so it's important to set up our what we call as dead letter queue for asynchronous invocation. So what this dead letter queue does is, if there are certain messages that are unprocessed, that can go to the dead letter queue, and then later you can do some analysis on why those messages have failed. So mostly, say if it's a sync invocation, then you're going to send either the response or some error code to the user. But when it's asynchronous invocation, as we had discussed in the previous video, there is not any response that the service that is invoked is expecting. So what you do is you can set some tries. So if it's failed once, then you try it second time, or you could try it third time. And even if it fails in all the 3 turns, then you can send that message to the dead letter queue. So you prevent the message loss in case of failure. So let me quickly show you. So I'm on the Lambda function. So I go to configurations, I go to asynchronous invocation. So here you can see maximum age of events, retry attempts, dead letter queue. So I do an edit, and then I can set the maximum amount of time to keep the unprocessed event in the queue. Then I can do how many times should it retry before returning error. So I can say 0, 1, 2. And then you can also set up a dead letter queue. So you can either have it as part of SQS or SNS. Usually you'll keep it in the SQS. So then you would be able to permanently store the failed messages to do the analysis later on. So those were some of the key 10 concepts that you need to know about AWS Lambda. Okay, so this series is part of a course that I've created on AWS Lambda and Python full course, beginners to advanced. So it's got some great ratings. You can see here more than 25 ratings with 4.5 stars, and it's a completely hands-on with 2 enterprise use cases. So if you want to check it further, I'll put the link of this course in the description and comments.